Hello students, welcome back to the session. Once again we are continuing with the same chapter, that is system of particles and rotational motion. Students, till now we have seen how to calculate moment of inertia of a rod of discrete particles, then ring, sphere, hollow as well as solid. Now today let us discuss some numericals which are based on the concept of how to find moment of inertia for different arrangement of particle. This is very essential because in your board exam as well as in the entrance exam, due weightage is given to this particular topic. So the first question that we need to discuss is this way: calculate the moment of inertia. This here I have written in short as MI. So moment of inertia of the given particle system about the axis AB and axis CD. Please understand here, the axis AB is this one. This is axis AB and this is axis CD. Axis AB is passing through the point here. Now students, how to find moment of inertia? So how to approach this question? All the particles are discrete: 1 kg, 2 kg, 3 kg, 4 kg. Here we are having different masses at different position. So what we will say, we know moment of inertia is sigma of mi ri square. This is what we have. So this can be written as I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. This is what we have as the general formula for finding moment of inertia when discrete particles are given. Now moment of inertia about AB as the axis. First I am taking about AB as the axis. So M1, what is the distance of M1 from the axis of rotation? This R is the distance of the particle from the axis of rotation. R1 is the distance of M1 from the axis. R2 is the distance of M2 from the axis. Like that, R3 is the distance of M3 from the axis. Similarly, R4 is the distance of M4 from the axis. So our axis here is AB. So what is the distance of mass M1? That is 1 kg. So I will write here 1 kg and distance is 0 because this is 1 because here the axis is first mass 1 kg is at a distance of 1 meter plus second mass is 2 kg. It is at a distance of 2 meters from AB. Then 3 kg is at a distance of 3 meters. Finally 4 kg is at a distance of 4. So what we get this as? This is 1 plus this is 2 cube 8 plus 3 cube 27 plus 4 cube is 64. So what we get here, this is what we get is, on addition of this is 9 87 4 and this is 11 19 20 0 carry 2 6 7 8, this is 100. What will be the unit? Kg meter square. How did we get the unit? Mass square of the distance. So we get kg square of the distance meter square. This is exactly how we can find for moment of inertia about AB. This is about the axis. If you remember, we had discussed that the moment of inertia depends on axis. So the axis is AB. Now ICD we want. Moment of inertia ICD. Again the same thing. m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. But here students, m1, m2, m3, m4 will be same, but r1, r2, r3, r4 is not going to remain the same, they will change. So what we get? 1. What is the distance of 1 kg from CD? CD is here. So what is the distance of 1 kg? See here, this is 4 meter, correct? So how much will be distance of 2 kg? See, this is 3 meter. So this is your 1 meter, correct? And this is your 2 meter. And this is your 1 meter. This is what we get by simple calculation, correct? So what is the distance of 1 kg mass from CD? It is 2 meter. So it is 2 square. Let us go to the next one, 2 kg. What is the distance of 2 kg from the axis CD? It is 1 meter. So then 3 kg. What is the distance of 3 kg? It is on the axis. Therefore it is 0 plus 4. What is the distance of 4 kg from CD? 1. So we can say, now this will be how much? This is 4, this is 2, this is 0 plus this is 4. So this gives us 10 kg. So ICD is this much. Please students observe, IAB is 100 kg per meter square, ICD is becoming 10 kg meter square. So what we conclude from this question, that moment of inertia depends on the axis that we are considering for the distribution of the masses. Students, let us take one more question. The next question is this way: calculate the moment of inertia about the axis xx dash in the following figures. So the first figure, now what exactly is moment of inertia? Let us first understand that. So moment of inertia is given as, we know moment of inertia is given as sigma of mi ri square, I is equal to 1 to n, we say. Out here we are having 2 particles, out here we are having 3 particles. So now if I take A part, we have to find moment of inertia about the axis of rotation is xx dash. So I xx dash. Cultivate the habit of writing this way so that you won't have any confusion to find if there is mistake in the calculation. I is xx dash. This will be, we will write m1 r1 square plus m2 r2 square. Because there are only 2 particles, we will take it this way. Now what is r1 and what is r2? r1 is the distance of m1 from the axis of rotation. So here please concentrate. m1 is what? Let us say 4 kg. 4 kg. What is the distance of 4 kg mass from the axis of rotation? Please observe, this is given as 100 centimeter and this is given as 70 centimeter. Therefore this distance we can say it is 30 centimeter and this distance we can say it is 80 centimeter from the axis of rotation. This is what we can find out from the data which is given in the question. So this will be 0.3 square. Why? Because we are taking it in SI units, plus the other mass is 1 kg. 1 kg is at a distance of 0.8. So this is whole square. So this gives us what? 4 into 0.09 plus 0.64. This is what we get. So this is nothing but 0.36 plus 0.64. So this is 0, 0, this is 1 and kg meter square. This is what you have, IIXX dash. This is exactly how. So student, so always try to remember this equation and then extend it. See, the same thing we will do for B. For B, again the same equation, how to use. There are three particles, so Ixx dash in this case will be m1 r1 square plus m2 r2 square plus m3 r3 square, because there are three particles we will write like this. Now m1, let us say m1 is 4 kg, then r1 will be the distance of 4 kg from the axis of rotation. Now 4 kg axis of rotation is xx dash, so what will be the distance of 4 kg mass? The coordinates are given 0, 3, therefore the distance of 4 kg mass from the axis of rotation is 3, so we will say 3 square. The next mass, let us say 2 kg, 2 kg is the other mass, so 2 kg, what is the distance? Coordinate is given minus 2, so you will write minus 2 square plus m3 is 3 and minus 4 square. Of course, when you are taking distance, we can drop the minus sign because it's a whole square term. So this is how much? 9, 4, 36 plus this is how much? 4, 2, 8 plus this is how much? 16 into 3, 48. So this will be how much? That is exactly how we can write Ixx dash as 92 kg meter square. This is how. Please understand how exactly we can find out. It is only to be remembered, moment of inertia is nothing but mass times square of the distance of the mass from the axis. Well students, the next question reads like this. 4 bodies of masses 5 kg, 2 kg, 3 kg and 4 kg respectively are placed at the positions 0, 0, 2, 0, 0, 3, minus 2. Find the moment of inertia of the system of bodies about x-axis and y-axis. Well, if you see the arrangement, if we see the arrangement, it says first particle is at 0, 0. So what we have is, here I am having 5 kg mass 0, 0. Here we are placing 5 kg. Then 2 kg is at 2, 0. This is 2, 0. 2 kg is placed there. 0, 3, 3 kg. This is 3 kg and 0, 3. 4 kg is at minus 2, minus 2. X is minus 2, Y is minus 2. This is minus 2, minus 2. Here we have placed 4 kg mass. Well, now students, what is asked? What is asked is find moment of inertia about x-axis. Moment of inertia about x-axis. This will be m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square, because there are 4 particles. So this is how we can write. Now, how to start with m1? Take anyone as m1. Let us say 5 kg. m1. What is the distance? r1 is what? r1 is the distance from the axis of rotation. So axis of rotation is taken as x-axis. So it is at origin. The second one I am taking is 2 kg. 2 kg. What is the distance of 2 kg from the axis of rotation? X-axis. This is our x-axis and this is our y-axis. So what is the distance of 2 kg mass from x-axis? 0, because it is on the x-axis. That is why it is 0. M3, let us say M3 is 3 kg. 3 kg. This 3 kg mass, what is the distance from x-axis? This is x-axis. This is 3. So 3 units is the distance. So it is 3 square plus M4 is 4 kg. What is the distance of 4 kg mass from x-axis? Minus 2 units. So it is minus 2 square. This is what we get. So simplify. From this we can say Ix is equal to, this is 0 plus this is also 0 plus this is 27 plus this is 416. So we get what? Ix equal to 43 kg meter square. This is exactly what we get as Ix. This is about x-axis. Remember, the x coordinate of a point is the distance of the point from y-axis. Y coordinate of the point is the distance of the point from x-axis. See here, this is x-axis and the y coordinate is 3. So that is your distance from the x-axis. Now here you see this 2, the x coordinate will give you the distance from y-axis. Don't be under the impression that x coordinate is the distance from x-axis. Don't substitute that. Please remember. So Ix is this. Similarly, Iy. How will you find Iy? So in order to find Iy, again here what it will be? It will be M1. M1 is 5 and this is 0 square. Plus M2. M2 is 2. What is the distance of 2 kg from y-axis? The x coordinate, that is 2. So it is 2 square. Plus 3. 3 kg. What is the distance from y-axis? 0. 4. So what we will write? Plus 3 and 4 minus 2. This is exactly what we have. So from this we can say Iy is equal to 8 plus 16. This is exactly how we can get Iy. Now suppose that it is said what will be the moment of inertia about z-axis. Students, we have seen that Iz is equal to Ix plus Iy. We have seen this. So Ix is how much? Ix we got as 43. So it is 43 plus Iy is how much? 24. So this is 67. See, if you know this concept, that is the perpendicular axis theorem, Ix and Iy was known. Suppose the question is extended, find the moment of inertia about z-axis. No worries, we can use the perpendicular axis theorem and we can generate the value of Iz. Well students, now let us take the next question. The next question is like this. Two masses M1 and M2 are placed at a separation R. Find the moment of inertia of the system about an axis passing through its center of mass and perpendicular to the line joining the masses. So if we have a rough diagram what the question says, it will become very easy. Two masses are there. Please understand here. Let us say this is M1 and this is M2. So M1 is here, M2 is here. Two masses M1 and M2 are placed at a separation R. The question says this distance is R. Now what it says, let us say the center of mass somewhere here, the center of mass lies. Let the distance be R1 and let this be R2, distance of center of mass. This is what we have. So now how to solve this question? Now moment of inertia through the axis passing through the center of mass like this. This is the axis of rotation. Then I will be m1 r1 square plus m2 r2 square. See, the distance of m1 is r1 from the center of mass. Distance of m2 from center of mass is r2. Hence we get I is equal to m1 r1 square plus m2 r2 square. Now how much is r1 and r2? But m1 r1 is equal to m2 r2. Why? Center of mass. If you say this coordinate of this is minus of r1 comma 0, and here the coordinate is r2 comma 0, and the center of mass is 0 comma 0. Now please apply the concept of x coordinate of center of mass is m1 x1 plus m2 x2 upon m1 plus m2. This is what we have. We know from the Cartesian system of finding center of mass coordinate. Now it is given 0. This is m1. What is x1? Minus r1 plus m2, and this is r2 upon this is m1 plus m2. Cross multiply. From this we get m1 r1 is equal to m2 r2. Please understand this. This is what I am using here. So from this we can say m1 r1 upon m2 is your r2. Also r1 plus r2 is r. See the diagram. r1 plus r2 is r. So r1 plus what will be r2? r2 is m1 r1 by m2. This is r. So what we get from this r1 as? From this r1 will be m2 by m1 plus m2 times r. This is r1. Similarly, r2 will be m1 upon m1 plus m2 into r. We got r1, we got r2. Now substitute. Now I is equal to m1 r1 square plus m2 r2 square. So therefore I is equal to m1 r1 square will give us m2 square r square by m1 plus m2 whole square plus m1 square r square by m1 plus m2 whole square. If you simplify this, what you will get? How to simplify? m1 m2 r square is common. m1 m2 r square is common. What we get? m2 plus m1. We get this as m2 plus m1. So finally the moment of inertia is m1 m2 upon m1 plus m2, because one here m1 m2 and here there are two m1 m2, they get cancelled out, and we get r square. This is exactly how we can find out moment of inertia of this system about center of mass. This is an important question. Students, you please try once again from your own side and try to compare the answer. That is how moment of inertia can be calculated. The next question reads like this: two identical rods each of mass m and length L, each of mass m and length L are kept according to the figure. Find the moment of inertia of the rods about an axis passing through O and perpendicular to the plane of the rods. So how exactly are we going to solve this? Now here, moment of inertia about O, this is, since it is made up of two rods, so this will be I1 plus I2. Let us say this is 1 and this is 2. Now closely observe. I1 will be what? I1 is moment of inertia of a rod. Axis is passing through one end of it, and we know what is moment of inertia of a rod when the axis passes through one end, that is m L square by 3. And the second one, again axis is passing through, it is this way, so again it will be ml square by 3. This is also ml square by 3, so this is also ml square by 3. So the required moment of inertia about O is 2 by 3 ml square. That is exactly how we can solve if such figures are given to us. Please understand, moment of inertia about a given axis is algebraic sum of moment of inertia of each particle that the system is made up of. So here, considering this is one part, this is second part, that is why we are writing here I is equal to I1 plus I2. That is exactly what is the approach. Whether it is a rod or whether it is discrete particles, we are going to use the same concept. The next question is like this. This is a bit conceptual question. A uniform wire of length L and mass m is bent in the shape of a semicircle of radius r, as shown in figure. Calculate the moment of inertia about the xx dash axis. Now we want moment of inertia about xx dash. It's a ring. Xx dash can be seen as a diameter. We have seen in the previous class how to find moment of inertia about a diameter. Now here, xx dash is diameter. So therefore, Ixx dash is nothing but I diameter of the ring. Now we know moment of inertia of a ring is mr square. Now that is from the central axis. Now use perpendicular axis theorem. Iz is equal to Ix plus Iy. Ix, we have seen this in the previous class. Ix is a diameter, Iy is a diameter. Therefore I along the center, that is mr square, is 2 times I diameter. So I diameter is what? Mr square by 2. So for what we can conclude, Ixx dash will be mr square by 2. Now L is given as 2 pi r. So r is equal to L upon 2 pi. So therefore Ixx dash will be m by 2 and r square. So that is L square upon 4 pi square, and that is how much? ml square upon 8 pi square. That is exactly how we can find out moment of inertia of any figure which is transformed. See here we had a length L, it was transformed into a circle. Then how to find moment of inertia? Please understand this. Well students, let us take one more question. The question reads like this: the moment of inertia of a sphere is 40 kg meter square about its diameter as the axis. So if we see it as a this is the diameter as its axis. Find the moment of inertia of the sphere about any tangent. So what is asked is about this tangent. What will be this distance? It is radius. Carefully observe. The two axes are mutually parallel to each other. So let us use parallel axis theorem. So we can say we know from parallel axis theorem moment of inertia about any axis is moment of inertia about the central axis plus mass times square of the distance between them. So here I will be, what is the moment of inertia about the center for a sphere? 2 by 5 mr square. We have seen that. I have considered it as a solid. Unless until mentioned, assume it as a solid sphere. Plus mass times distance between them is r. So r square. So what we get? mr square. So 7 by 5 mr square. This is what we get. Now it says moment of inertia of the sphere about its diameter is 40. So I diameter is given as 40. I diameter means 2 by 5 mr square is 40. So we get 7 by 5. So you can say 1 by 5 mr square is 20. So this we can use here. Please use this equation here. How? 7 into 1 by 5 mr square. So mr square 20, so it is 140 kg meter square is your answer. See how by rearranging the term, there is no need of mass data, there is no need of radius data for the sphere. This is how we can evaluate such questions. The next question, this is a conceptual question. Please try to understand. The radius of gyration of a solid sphere, it is given solid sphere of radius r about a certain axis is r. So what is given? So we can write k. We normally represent radius of gyration by k. So it is given k is equal to r. Find the distance of that axis from the center of the sphere. You have to find this distance. Now we know from parallel axis theorem because the two axes are parallel axis theorem, I is equal to I about the center plus mass times this is what we have. So here I will be mk square is equal to 2 by 5 mr square plus md square. But k is equal to r. So therefore mr square is equal to 2 by 5 mr square plus md square. So what we can say now? md square is equal to 3 by 5 mr square. So m cancels out. So we can say what? d square is equal to 3 by 5 r square. So therefore d is equal to root of 3 by 5 r. This is exactly how we can find out the distance of that axis from the center of the sphere about which the radius of gyration is r. Well students, see this question. This is a very typical question. Find the moment of inertia of the ring shown in figure about the axis AB. About this axis we have to find. Please observe, the given axis is parallel to diameter. Because axis of the ring is this way. Correct? So we have to first of all find moment of inertia about the diameter and then apply parallel axis theorem. So first, what we will do? I about Z can be said as Ix plus Iy. They are diameter. So I get I mr square is equal to I dia, this is also diameter. So this means that I about the diameter is mr square by 2. Now from parallel axis theorem, this is perpendicular axis theorem. Now from parallel axis theorem, IAB can be said as I, or we say I is equal to I center plus mass times square of the distance we said. This is what we get from parallel axis theorem. So here transform. So IAB is I dia plus M. What is the distance between them? R square. So how much is I diameter? We found out it is mr square by 2. So it is m r square by 2 plus mr square. So that is 3 by 2 mr square. This is what we get as moment of inertia about AB. Please understand how to apply, where to apply parallel axis theorem and perpendicular axis theorem. Here observe, the axis of this ring is this way. This is the axis, and about this axis only we have mr square. And observe, this is perpendicular to the diameter, na? So that is why first we are converting the axis, centroidal axis, into diameter. How? By using perpendicular axis theorem. Once we got I diameter, now the diameter and the given axis, they are parallel, so use parallel axis theorem. This is exactly how we are utilizing the two theorems of moment of inertia to solve such questions. This question is also a typical one. Students, please concentrate. 4 spheres each of diameter 2a and mass m are placed with their centers lying on the 4 corners of a square of side AB. So let us try to draw a figure which will represent it. This A, B, C, D corners. Now what it says is we are having 4 spheres. So let us place 4 spheres. This is 1, 2, 3, 4, each of mass m and radius a. Now what we have to find? It says that calculate the moment of inertia of the system about one side of the square taken as the axis. Let us say this is the axis. This is the axis. So what we can say? Axis BC. So now moment of inertia of the system, this will be what? First, mi of A about BC plus mi of B about BC plus moment of inertia of C about BC plus moment of inertia of D about BC. This is what we can say, because we know moment of inertia is sigma of mr square, which means individual moment of inertia we have to add. We have seen in the previous question also. So this will give us moment of inertia of A about BC. Please see this one. So first, by knowing that it's a solid sphere, 2 by 5 mr square, so it will be 2 by 5 m a square plus, use parallel axis theorem. What is the distance? Side is given as B, this side is B, so it is mass times B square. This is moment of inertia of A about BC. Second, moment of inertia of B about BC. Axis is passing through B, therefore it will be 2 by 5 m a square only, plus, now axis is passing through C, so it is also 2 by 5 m a square. And what about D? Again 2 by 5 m a square plus m b square. This is what we get. Please understand, it is conceptual. Finally, what we get? 2 by 5 ma square, 4, 6, 8. So we get this as 8 by 5 ma square plus mb square plus mb square 2 times mb square. That is exactly how we can find moment of inertia for such distribution of masses, and then axis is also different. Please understand this question properly.